Today we're going to talk about 6-4 day 2. We're going to analyze graphs some more. All right. So obviously in the first one, we're going to graph this function. And the only way that we know how to do that for cubic functions is to use our calculator. So if you go to your calculator and you would do exactly what we did yesterday, where you would type in x to the third minus 3x plus 1. Okay. Once we do that, we can start graphing. Right, so we're going to approximate our zeros. So we would do second calc and go to our 0, right? And then we do our left bound. I go all the way to the left, somewhere over here. Hit enter. Then we're going to go all the way to the right, past the x-axis, hit enter. Enter one more time. And there is our first 0. So negative 1.90. So negative 1.90. So I'm going to plot that almost at -2. Right? And drop my pen. We could do the same thing on the other 0. So back to our calculator. Second trace. Go to our 0. Then we're going to arrow over a little closer to the next 0. Hit enter. Then we go past it. Hit enter. Hit enter one more time. And we get 0.34, technically 35. So 0.35 would be our next one. I'm going to plot that one as well. And then we have one more. Second trace down to our 0. We're going to move over a little bit. Now we are left of it. Move over to the right of it. Hit enter twice. And that is 1.50. And we'll graph that one. Okay. So at that point, we have our 3 zeros, but we can also find our maximum and minimum. And remember, that is done the exact same way. So second calc, go down to, we're going to do the maximum first. Okay. Oops, stop. So my relative max over here where it is like a hill. So again, we go to the left of it, and then we go to the right of it, and then we hit enter again, and it tells you what your highest point is, which is basically -1, right? -1.3. So I'm fine if you round that because it's very close to -1. So we're going to do -1.3 as our maximum. And then our minimum, done the exact same way. Second trace, go to your minimum. Then we're going to go somewhere to the left of this minimum. Make sure you go all the way, for sure, past minimum. And that is basically -1. Oh, wrong spot, sorry. After you have all those plotted, you can then graph it. So we would start like this and finish off up here. Okay, so that was definitely a recap of what we did yesterday. We're going to do a little bit more work with it. So I would use your calculator right now and try to find these answers. I will walk you through some of it, but again, a lot of it we're going to end up using our calculator for, and I don't think that I need to continuously show you on the calculator on here. If you have questions on that, please ask either in class or shoot me an email and I could walk you through it. Okay, so go ahead and try these on your own. All right, as you can see, I have added in the points for real zeros, relative min, relative max, and I have plotted those points. Okay, those are things that I feel like you can do on your own, and you will be able to do that with your calculator, just like I showed you in the first one. Okay, So now from here, remember you always just want to connect it from left to right. So just basically just start wherever you feel like makes sense and how you can just go from left to right and connect the dots that you put from your calculator. Okay, so that's what the graph is going to look like. So because of this, okay, as x is approaching positive infinity, aka going to the right, f of x or y is going up, which is positive infinity. As it goes to the left, it's going down, so negative infinity, okay? And remember, you could basically get that from this equation. It's positive and odd, so that means that it's going to match whatever the x's are over here, okay? Remember, minimum number of turning points is your degree minus 2. So if my degree is 3, or sorry, your degree minus 1, which would make your answer 2 here, because 3 minus 1 is 2. Your maximum number of zeros is your degrees, so the maximum is 3, which we have 3. You don't have to have 3, you could have less than 3, but the maximum number that we can have is your degree. Okay? Domain, it goes all the way to the left and all the way to the right, and it does the same thing with your range, all the way down and all the way up. So positive and negative. Example 2, I did the same thing. I've already put in the zeros, the relative mins, the relative maxes, and I have plotted them on the graph. So if you haven't done so, make sure you do that right now. Then we have the same situation with our end behavior. So as x goes to the right versus x going to the left. Again, remember, this is a positive and odd, so it would match. We should go positive and negative infinity. Again, if we wanted to graph it first, you would start down here, connect them, and go up, right? Again, just start from the left. Maximum number of turning points is your degree minus 1, which again gives us 2 this time. Maximum number of zeros is your degree, which is 3, and we do have all 3 here. And once again, your domain and range are all values, right? There's nothing that will not be included from both of those. All right, and then our last one, this is still an odd function, but it is negative. So remember, your values are going to flip then. Okay, so this would be negative infinity and then positive infinity, which if you look at your graph, it would start up and work its way down. So as it goes to the right, it's going down. As it goes to the left, it's going up. So it'd be negative and then positive infinity. Still, our maximum number of turning points is 2 right now. Remember, it's not always going to be 2. It's your degree minus 1. Same thing with zeros. It's going to be 3 again because our degree is 3. We do have all 3 zeros, but you don't always have them. Sometimes they're imaginary. Your relative min, your relative maxes are there, and then your domain and range, yet again, are negative, positive infinity. Now, once again, that's not always going to be the case, but these are the ones that students struggle with the most. So we wanted to make sure that we went over this again. Okay, remember, use your calculator for these. If you need me to send you another video explaining why I got what I got, let me know, okay?